Hey, all you cool cats and kittens. Sorry, I couldn't help myself. If you get that reference, I think I might feel sorry for you. If you don't get that reference, it's probably a good thing, maybe. How you doing out there, everybody? I hope everyone's doing well, everyone's safe, everyone's sane. I know this is a difficult time for a lot of people, but welcome to the next chapter of Applied Geometry. We're going to be moving into chapter 10. This is a chapter on area and volume. If you've read my last email, you understand that your grade can only improve from what it's currently at. So if you are paying attention to this, if you're doing this, which I hope you all are, I'm going to be going over the lesson as we would in class right now. And then there will be a 10.1 assignment up on Math Excel. You should first do the notes, learn how to do the assignment, and then log on to Math Excel and do the assignment. So let's get after it. 10.1 areas of parallelograms and triangles. A parallelogram is a rectangle that has kind of been tilted on its axes. This right here is a parallelogram. Due to this, the method to find the area of a parallelogram is very similar to that method of finding the area of a rectangle. If we have a regular old rectangle here, you find the area by taking the base times the height, or the length times the width. It's a two-dimensional figure, and you multiply together the two dimensions. A parallelogram is exactly the same. However, the one importance of a parallelogram is that when you take the height here must come perpendicular to the base. So what you might be seeing here is we have a right triangle. So yes, right triangles are going to come back in this section. We're going to be using right triangles to be able to find out heights of parallelograms. The height of a parallelogram, though, has a special name. It's called the altitude. It's the altitude of the parallelogram. So this altitude can either be found by going inside of the parallelogram, or you could even kind of extend the base and you could have that go outside the parallelogram. But regardless of whether you come perpendicularly down and then call this the base, or if you want to call this the base and go outside of it, that's the altitude. So let's do a couple example problems. Find the area of each of the parallelograms. This diagonal is 4.5 inches, but we are not going to use it in any way, shape, or form because we have the altitude of 4 inches. So this is the altitude. So we know that the area is going to equal the base times the altitude. And we use little a for altitude, capital A for area. So the base is 5, the altitude is 4, and 5 times 4 is obviously 20. That was exhilarating. Now let's go to option B here. This is an option where the altitude comes outside. This altitude came inside. This altitude's going to go outside. Again, I am not going to use this diagonal for anything. I have the base and I have the altitude. That's all I need in order to find the area, is the base and the altitude. So I have that the area is going to equal the base times the altitude. The base in this case is 2. The altitude in this case is 3.5. So the area is 7 squared centimeters. Flip it over. That was pretty short, right? Get on to our next page. What is the measure of d to e to the nearest tenth? So this is asking us to go a little bit different way. We understand that the area is going to equal the base times the altitude. Well, I am given an altitude here of 9. This 9 is an altitude. And if I use this altitude of 9 up here in the corner, this 13 is going to be my base. 13 is my base with the altitude of 9. So I have that the area is going to equal 13 times 9. And 13 times 9 is 117. Now, we're going to use this 117 to find the distance from D to E. The distance from D to E we can call x. But if you recognize, this distance is also an altitude. This is an altitude of this parallelogram with the base of 9.4. So we could create another equation that the area is going to equal the base of 9.4 multiplied by x. X is the thing we're trying to find. But we know what the area is. We just found the area. The area must be 117. So now we have an equation that we can solve by dividing by 9.4. When you take 117 and you divide that by 9.4, you get about 12.4 to the nearest tenth. And that would be in inches. All right, areas of a triangle. A triangle can always be created by cutting a parallelogram in half. If we take this parallelogram over here, we cut it in half. That's the exact same rectangle, this same triangle that we have here. Therefore, the area of a triangle is equal to half the area of a parallelogram. So here is your equation. The area is going to equal 1/2 the base times the height. But again, that height must go perpendicular to the base. So this right here could also be called the altitude of the triangle. So here we have an example problem. You want to make a triangular sail like the one at the right. How many square feet of material do you need? How much material do we need? Well, we have 12 feet 2 inches. We have 13 feet 4 inches. So we need to work with this 2 inches and the 4 inches. So I have 12 feet and 2 inches. Well, I need to make that into a decimal. That is 12 feet and 2/12 of a foot. There are 2 inches. There are 12 inches in 1 foot. So 12 and 2/12, which is 12 and 1/6. Now we have to do the exact same thing with 13 feet and 4 inches. So I have 13 feet. I have 4 inches. That's 13 feet with 4/12 of a foot, which is 13 and 1/3. So I take 12 and 1/6. I add 12 with 1/6, getting 73/6. The area is going to equal 1/2 the base times the height. We just said that our height is 73/6. And our base would be 13 and 1/3. Make that into a fraction. 13 into 1/3 is 13.333 repeating, but as a fraction, that is 40/3. And 73/6. So now I have to multiply all these fractions together. I have a half times 40 thirds times 73 sixths. Multiply top times top, bottom times bottom. So 2 times 3 is 6, times 6 is 36. And 40 times 73 is, got to do that on my calculator here, 40 times 73 is 2,920. Divide that by 36. Make it into a fraction. 730 over 9. 730 over 9, or 81.1. That'd be square feet. Last but not least, what is the total area of this figure? Well, it'd be taking the area of the square. This is a square because this side equals this side, which equals this side. So all the sides are equal. And then adding it with the area of the triangle. So I'm going to add the triangle with the square. So the area of the triangle is going to be 1/2 my base times my height. And my square is going to be 6 times 6. My base of my triangle is 6. So I have 1/2 base times height. 1/2 of 6 is 3. 3 times 8 plus 36. 3 times 8 is 24. And 24 plus 36 is 60. 60 square inches is the total. And that's all there is to this lesson, guys. It's a pretty short thing. You will have questions, though, on your Math Excel assignment that ask you to use right triangles to find your altitude. Okay? They might tell you that your altitude is something, but they might not tell you what your base is. And you're going to have to use SOHCAHTOA to find what your altitude or your base is using a right triangle. So that's the only thing that could possibly show up on your homework. It's just using what we've talked about last chapter. Miss you all. Hope you guys are all staying safe, and good luck this week on your assignments and all your work that you have to do. Stay safe, everybody.